S equals R theta. Let's set this problem up. In a little bit, we're going to go outside at the exact same time, and we're going to measure some shadows. These shadows come from the rays from the sun, caused by those. So you can kind of see where we're tying this all in, hopefully, and I'll hammer it home a little bit here. Here is a picture of the Earth. In a minute, we are going to go outside, and we are going to stick a meter stick in the air and measure its shadow. There's us in Pennsylvania. You guys at the exact same time over here in Kingman, Arizona are going to do the same thing. You're going to stick a meter stick in and you're going to measure the shadow. Now, if we had a super long meter stick, like way more than 1 meter stick, and we extended these lines to go to the center of the Earth, our picture would look something like this. So now we have to use the radius of the Earth to kind of help us figure this out. We have our formula. The arc length equals the radius times how many radians you are actually looking at, how many radians you rotate it through. So I have this radius of the Earth. We're going to rotate it through a certain number of radians, and we're going to have this radius of the Earth. We're talking about arc length. The goal of this nearpod, the goal of this activity, is to find the distance that we are apart from Mechanicsburg, or on this circle, this great big circle that's Earth, to Kingman, Arizona. So we have our S equals our theta. We're going to have to find, we'll use the radius of the Earth. We'll look that up and we'll use a value for that in miles. And then theta is what we're going to have to figure out. If we times those together, the radius times how many radians, that will tell us the arc length, which is the distance we are apart.